lot of times in PostgreSQL or in any database, what we do is we create an association between two tables with the help of a foreign key, and that acts as an index from one table onto another. So there's an index created in PG indexes, and that mainly ties up your one table with another, and that is the way to do belongs to relationship, has many, like we do in Rails. But let's say you feel like there is a strict use case of column sharing in between two tables. Then the best way to go about it might be inheritance. If you want to utilize inheritance right off the bat without having to do it in your ORM, you can do it and share some columns and also have a relationship, so that if the child of a table is also going to be a table, but if a child is updated, the parent is updated as well. If there is, unless you specify a strict conditional. So let's dive right into it. All right, well, let's say I have a table named animals. So I'm gonna utilize a pretty simple example to go through and help us all learn about inheritance. So let's say we have animals table where animal has a name. I could also use, instead of varchar, I could also do like text. It's fine. That is not the main point of this discussion. Let's say I have an animal table where I have a name, sound, and number of leg, which is an integer. I could provide like ID, which is primary key, etc. But that's not point. This is not basic Postgres. I am assuming you guys have good understanding of basic primary keys, foreign keys, etc. If you don't, let me know. I can also create some beginner relation. So let's say I have a table animals. I'm gonna create this table animals. All right, all completed. I added if not exist, which is important if it just checks that a table doesn't exist before it creates it. So it's just kind of a better way to do error catching in case it happens. So now if I do this, let's say like see relation animal exists, it skips instead of throwing an error, which is good practice. So now how we go about creating an inheritance pattern over there. Let's say I want to create another table which is humans, and I want all these columns, name, sound, and number of leg to be available in humans as well. But human have another attribute, another column, which is let's say reading speed. All right, so how do we create it? So we do this create table if not exist. I will name this as humans. Now whatever column you want to specify, so I want to specify reading speed, which would be, let's do it, let's name it, let's appoint it an integer data type. And now is the main gist of it. We provide inherit bracket which table you want to inherit with. So I want to inherit with animals. All right. PostgreSQL provides us capability to reuse multiple tables and compose or actually create a hierarchical structure from multiple tables. So let's say I also have investments. Yeah, that is better. Investments. Investments. All right, and investment is capital is, let's say, float. All right, and let's say this is a table and you want humans to have both characteristic of animals and this particular column capital. Then what you can do is you can add investments here, and yeah, now the table created would have the column from animal, which would be name, sound, number of leg, from investment, which would be capital, and lastly its own attribute, which should be reading speed. So that pretty much that solves a lot of issue with respect to drying up your code, and you can reutilize schema, and you can have updates available, so that if human is updated, then corresponding column is updated in animals as well, or in investments as well. That's pretty cool feature of Postgres you could utilize. But let's not get into multiple inheritance right now. Let's start with single inheritance. And yeah, as I showed in the example, if you're interested, go give it a try. Like try inheriting from multiple table. That would be your homework. All right. But let's take a look into few of the operation. And how would you go about doing insert, select, delete, update, and dropping tables. All right, I would remove parent, because we would like to take a look at both scenarios. So over here we have create table, if not blah blah blah, insert. So how do we go about doing that? Insert into I just want to insert it to humans maybe. All right, of course you would understand insert into animals is pretty simple. You just provide a name, sound, and number of leg as row values, and you would have a new row, right? Or actually I should say column values, and you'd have a row added. But so that's nothing fancy, just simple insert from PostgreSQL. But with respect to humans, let's see what happens when we insert something in human. Okay, insert into humans values. Now you provide the values here. So the first value would be, let's say I only want to provide reading speed. All right, what happens when I just add reading speed? Okay, through this example, through this insert, I want to show you the order of the columns. So what do you think? Reading speed would be the first one, or would it be the last one? Let's take a look into that. So let's say I add like 100 words per minute. Relation, I have to run these queries first. All right, so relation animals already exist. Okay, since we created it, and I want to create a relation humans. This got created as well. Good, pretty good. Now I want to insert into humans, which again is whose superclass is animals. Okay, let's clear this up, and now I want to check it out. Okay, select all from humans. Of course you're gonna see humans, but let's start with animals. Well, we have one row inserted where the first value was 100. All right, but that got allotted to name, and name was text, so that is not the right way, right? It should be reading speed should be 100. So yeah, so the point of this overall example is that you have to follow the order. The parent table columns would have the first order, and then you'd have the column you described in the children table. So I'm going to delete it from here. Delete from humans. All right, cool. Is there anything here? Nope. I deleted from human the value, and the corresponding column created in animals also got deleted. So that's pretty cool and functional. Let's actually now do a proper insert. So what I'm gonna do is name, sound, number of leg, and reading speed. So name would be, let's say, cow. Actually no, that's humans, right? Sorry, Shasha. All right, name, sound would be hello. I don't know, English phonetics. Name, sound, number of leg. Now number of leg would be 2, and now the last would be reading speed, which would be 100. Now I did this. Output is one row affected. That's pretty cool. Now let's check animals. I have a Sasha entry, and there is a actually wait a second. Reading, I did provide reading speed. Oh, because for animals there's no reading speed. Makes sense. Now humans. Okay, let's see. So you can see like human, this, so that row which we inserted got inserted into both humans as well as animals. What I'm trying to say, see is use of only keyword. So let's actually start with select. Let's say I want to select only rows from animals and not from humans. Then I would have to select from only animals. All right, what do you think would be the answer? Well, there's none, because humans is the children, and that's where we have added the value. The value is not present if you provide the only keyword, which would look for all non-related values inserted into animals, where no children no children association or no children rows, I would say, exist in humans or any other hierarchical structure you have created. Let's try to do this. Select into humans. I'm trying to see if we could do this. Insert into animals. With the same logic, I'm trying to do the only keyword on animal, and I'm trying to see if that works or not, which would be pretty interesting. But it looks like insert into only animal. Can I do something like that? I'm not sure. Maybe not. All right, looks like this only keyword is not applicable for the children table itself in the inheritance pattern. Let's take a look into delete. What happens if I try to delete something from humans, how that affects the parent table, and also we will look into the effect of utilizing only into animals class. So for that to happen, I would like to add a value in animals to make sure that the value doesn't get deleted. Animals, oh come on, animals values would be, let's say, cow does actually mow, yeah. Cow speed, no, number of leg. All right, number of leg is 4, and that's pretty much what is available in animal. I added it here. Let's check humans. Human has just 1, which is Sasha, but animals should have now cow. Okay, now if I do select all from animals and remove the only, it would showcase all data in parent as well as not its own parent, but this table as well as the children table in inheritance pattern. Let's see. So you can see like this actually came from its own data, and this came from the children in hierarchical structure. Now let's try to delete something from humans. So I would like to delete this from human, and let's go from animals. So you can see like now animals only has data which was inserted into its own and not the human data. Well, now what I want to do is I want to delete from animals now and see the effect it has on humans. Okay, so for that to happen, I will add this value again, and now I have actually not only, and now I have both these rows. Pretty good. Now we go to delete, and what I want to do in delete is I just want to delete a value in the animals table, but not in the humans. Let's see if it is possible. Delete from only, so only is supported only after from. Insert into humans values, there's no from, so we can't really chain it into insert. But delete from only animals, okay, where number of leg equals 2. All right, let's see what happens. Okay, and let's select all from animals. So animal right now has only this. Previously, actually, one second, we'll select all from animals. So Sasha hello 2, it looks like it didn't get deleted. So delete from only animals where number of leg equal 2. I want to do it again, and let's see, let's check the console to make sure what is happening. All right, let's clear this out. Delete from only animals where number of leg is 2. Complete. Delete from only animals where number of leg is 2. Now, did it deleted it from animal or no? Let's see. Select all from only animals. Oh, well, from only animal, yes, it got deleted, but select all from animals, it didn't get deleted because that value is still in humans. TLDR is you would have to delete it from human to be able to not show it in this select all from animals. And if you just want to gather data from animals only, then you should always use one, like only after your from. That will give you the data only applicable to animals, you know, like the main class, the main table. And if you do select all, that will gather all the details from that table as well as the children hierarchical tables. Now let's same logic applies with update. So update humans set let's say sound equals, I don't know, let's say hey or YOLO. Set sound is YOLO where number of leg is 2, and now I'm doing it in humans. All right, so now let's go and check out humans. All right, and now the sound is YOLO. Let's check the animals as well, and the sound got updated over here as well because it's not really stored in the animals table. Animals, since Postgres is a object-oriented database, it supports the relationship. So when you are doing select all from animal, that all will be cascaded and it will go down the inheritance chain if you already have an inheritance in place. All right, now how do we go about dropping tables? Okay, so pretty simple. Drop table if exists. Okay, here again, create table if not exists, but drop table if exists. This is mainly for error proofing your code. It's a better code philosophy, code design. Of course, this would be deleted because there is no conditional applicable on humans. But if I do animals, let's see what happens, which is a base class for humans. Let's see what happens here. Whoops, we got an error which says cannot drop table animal because other objects. Again, we are in object-relational database, object-oriented programming. It supports it. So cannot drop table because other objects depend on it. All right. Detailed table humans depend on table animals. Use drop cascade to drop the dependent objects too. So if you want to drop the base table as well as other tables which are children table in the inheritance, then what you should do is just use this cascade keyword, and that is going to cascade all the way down and remove all the chain of inheritance you have created and remove the data as well. So the console message would give us more detail what exactly is going to happen. So see, drop table, it dropped the table, of course animals, and then it dropped, first it did drop and then it did a cascade which took the drop action and cascaded it down to the table humans, and so human table was also deleted. Let's make sure what I'm saying is all right. Human does not exist, animal does not exist. This was pretty much what I had to explain in this. Most people don't know these concepts, and these are advanced concepts, I would say, but it's good to try it out. It's good to think about the use cases and utilize it in your code design, utilize it in your database query which you are using on the backend. One last thing I wanted to reiterate is, again, Postgres provide multiple parent for one particular table. If you want an overall hierarchy like this, where you have an investment table and you want to reutilize the capital column, then what you do is you add here investments. Okay, and now humans would mainly, if you already know the concept, there would be multiple inheritance happening, and humans would be inheriting from columns from both investments as well as animals. All right, and yeah, you can have multiple over here. I would say give it a try and try the multiple inheritance on your end. All right, try it out. That's gonna be your homework. And if you want to read more about it on Postgres, let me see, I think I would have it open. Yep, there you go. So go for your version. This one, I think I'm on 13th version. Yep, the current version. And you can read more about inheritance over here. But of course, through the video, I wanted to give you an insight into more detail into all the operations, what you can do and what you cannot do. So really appreciate you guys over here. Hope this was helpful. See you again. Bye.